In this module, we will be discussing about polynomials. What are polynomials? Now, polynomials are algebraic expressions that consists of what? Variables and constant. Constants are also coefficients. Now the variables can have only non-negative powers. Let us take examples like 4x square minus 3x plus 7. This is p of x, variable in x. Now here variable in y. So let us take a linear polynomial. So 4y minus 3. Here the variable power is 2. Here variable power is 1. Here variable power is 1. You cannot have the variable power like this, minus 2 or minus 3 or y to the power minus 1. Variables in negative powers are not allowed. Then they are not polynomials. Primarily, we are interested in polynomials in single variable. That is, here there's one variable x, here one variable y. You cannot have multiple variables within one polynomial. But we will be dealing with the polynomials with the single variables, that too linear polynomials. The standard form of standard representation is ax plus b. So this is also known as the degree 1 polynomial. And then we'll be talking about quadratic polynomials. Standard representation is ax square plus bx plus c. So this is known as the degree 2. We will also be discussing about degree 3, degree 4, but primarily these two. Now you know ax plus b is the standard representation for linear polynomial. Ax square plus bx plus c is the standard representation for quadratic polynomial. Now let us discuss about the zeros of polynomial. So let us first take linear polynomial. So px is equal to ax plus b. So what is the zero of this polynomial? It is the value of x for which the value of the polynomial, becomes 0. That is, your ax plus b becomes 0 for some value of x. That value of x is known as the zero of the polynomial. The value of x for which the value of the polynomial becomes 0 is the zero of the polynomial. Let us take some example. So let us take An example, polynomial in variable x. So it is 4x plus 8. Now let us substitute the value of x equal to minus 2 in this polynomial. So it becomes 4 into minus 2 minus 8 plus 8, that is 0. Therefore, x equal to minus 2 is the 0 of polynomial 4x plus 8. Now how to find the 0 of any polynomial? Let us take this example again. 4x plus 8 is a polynomial. To find the 0 of this polynomial, equate this one to 0 and solve for x. So it is 4x equal to minus 8. Therefore, x equal to minus 8 divided by 4 equal to minus 2. This is how you find the 0 of the polynomial. Let us take the standard form of linear polynomials, that is p of x equal to ax plus b. So now let us equate this one to 0. Therefore, ax equal to minus b, or x equal to minus b by a. So x equal to minus b by a is the 0 of the polynomial ax plus b, or this also can be represented as minus. What is b? B is nothing but the constant term. It is the constant term minus of constant term divided by coefficient of the variable x. This is how you find out the 0 of linear polynomial. Now let us try to understand what is the meaning of the geometrical representation of 0 of the polynomial. That is the geometrical representation. Now let us take the same polynomial that what we discussed earlier. P of x equal to 4x plus 8. Now let us try to draw a graph of this polynomial. This is a linear polynomial. So if you draw a graph, you will have a straight line. So this is 1, 2, 3, 1, 2, 3. This is x-axis. This is y-axis. So 1, 2, 3, 4. 1, 2, 3, 4. The negative side. 2, 3, 4. So minus 1, minus 2, minus 3, minus 4. X-axis. Minus 1, minus 2, minus 3, minus 4. Now let us take this polynomial. Let us find 3 points. When x is equal to minus 1, x is equal to minus 1. Now this one you can also write as y equal to 4x plus 8. When x is equal to minus 1, this becomes minus 4 plus 8. So y equal to 8. So when x is equal to minus 1, y is equal to not 8, y equal to plus 4. Y equal to plus 4. So this becomes minus 1, 4, this point. Then x is equal to minus 2. This becomes minus 8 plus 8, it becomes 0. So this is the point when x is equal to minus 2. So this is minus 2, 0. Now when x is equal to, let us take now minus 3. When x is equal to minus 3, minus 12 plus 8, so it is minus 4. So when x equal to 3, this is the point, that is minus 3, minus 4. Now if you join these 3 points, let me try to draw a straight line. It's a little difficult on this. This is the line going through these points. So it cuts the x-axis at -2 and y is 0 at that time. Now we know in this case, in this example, the 0 is nothing but -2. So this is the point. Now we can say that the 0 of a linear polynomial is the x coordinates of the point where the graph cuts the x-axis. So in the case of a linear polynomial, if you draw the line where it cuts the x-axis, the coordinate, the x-coordinate of that point is the 0 of the polynomial. Is the 0 of the polynomial. So in case of a standard form of linear polynomial, that is ax plus b, we know the 0 is equal to minus b divided by a. So this is the 0 of the polynomial, or we can say this point as in a standard polynomial it is the minus b by a. This is the point at which the line cuts the x-axis and the coordinates of this point are minus b by a comma 0. 0 is y. So far we discussed about 0 of linear polynomial. Now let us discuss about the zeros of quadratic and higher order polynomials. Now let us take a quadratic polynomial. Say let us take p of x equal to x square minus x minus 6. Now you know how to find out the zeros of this one. You can equate this polynomial to 0, then factorize and then find out the zeros. That is x square minus x minus 6 equal to 0. Then if you split the midterm, this becomes x square minus 3x plus 2x minus 6 equal to 0. So take x out, x minus 3 plus take 2 out, x minus 3 equal to 0. Therefore x minus 3 into x plus 2 equal to 0. Therefore x equal to plus 3 or x equal to minus 2. So these are the two zeros of this quadratic polynomial. Now let us just try to represent this quadratic polynomial in a graph. So for that we need to find out some points. So let us draw a table. So for various values of x, we will find out the values of y. So here x will find out the value of y, substituting here. So now when x is equal to minus 3, y becomes 6. When x is equal to minus 2, y becomes 0. When x is equal to 0, y becomes minus 6. When x is equal to 1, then also it is minus 6. X is equal to 3, then y equal to 0. And when x is equal to 4, y is equal to 6. Now let us try to plot this one. Yeah, going to be 1, 2, 3, 4, 5, 6. So this is plus 6. 1, 2, 3, 4, 5, 6. So this is minus 6. 1, 2, 3, 4. So plus 4. 1, 2, 3, 4. This is minus 4. So the first point is minus 3 and plus 6. So minus 3 and plus 6. So the first point is here. The second point is minus 2 and 0. This is minus 2. So this is minus 3 comma 6. This point is minus 2 comma 0. Next point is 0 comma 6. So this is 0 comma minus 6. Then 1 comma minus 6. This is 1. So this point 1 comma minus 6. Then you have 3 comma 0. This is 3. So this is 3 comma 0. The last point what we have to plot is 4 comma 6. This is 4. This is 6. Now if you join all these points with a smooth curve, it will come like this. It has to go through this point, then turn back and go through this point, this is 4 comma 6. So now when you plot a quadratic polynomial, it is not a straight line, this is a parabola. Now the parabola cuts the x-axis in two places, and this is minus 2 and 0. Why is 0 here? Here it is 3 and 0. So earlier we found out the zeros of this quadratic polynomial, plus 3 and minus 2. So these are the points at which the parabola cuts the x-axis. So in case of quadratic polynomial 2, the zeros of the polynomial are the x coordinates of the point at which the graph, that is the parabola, cuts the x-axis. So the zeros of the polynomial are the x coordinates, that is, here is minus 2, here is 3. They are the zeros of the polynomial at which the graph, the parabola, cuts the x-axis. A quadratic polynomial has got maximum 2 zeros. It doesn't mean that you need to have 2 zeros. It can be 1 0 or nil also sometimes. So let us see how it is. Now suppose if we draw a graph of a quadratic polynomial, if the graph comes like this in this form, now at these two places the graph cuts the x-axis. So the x coordinates of these 2 points, x1 and x2, are the zeros of this quadratic polynomial. It need not come this way, it can be in the reverse way also. Say here, in this case these are the 2 points. So in this case it will have 2 zeros, but it can have just 1 0 also. How it look like? Now suppose the graph is like this. It just touches the x-axis and then goes back, or it can be in the reverse way also. here also. Now here also this graph, in both the cases, the graph just touches the x-axis, so it has got just one solution, say x1, or here also only one solution each. Now the third case where you don't have any solution. So if you plot the quadratic polynomial, then suppose the polynomial comes this way, or anywhere in any, or it can be on the in between the quadrants. In this case, it doesn't touch the x-axis at all. So now it is no zeros. Here it is 1 0. Here it is 2 zeros. Now if it is a cubic polynomial, then the maximum zeros you can have is 3. Or we can generalize that in any polynomial, maximum number of zeros is equal to the degree of the polynomial. If the polynomial of degree 5, you can maximum have 5 zeros, but doesn't mean that you need to have 5. You may not even have 1 0. Let us show if it is cubic polynomial, how the graph will look like in case it has got 3 solutions. So it may go like this. So in this case, it crosses the x-axis in 3 places. So these are the 3 zeros of this cubic polynomial.